Now we're going to talk about frequency and phase, which again I think is pretty cool. Frequency is what we perceive as the pitch of a sound. So if something sounds high or if something sounds low, that's frequency. Frequency is measured in hertz, and basically the faster the rate, the higher the frequency. So to explain hertz, hertz are cycles per second, so it's the measurement for frequency. Um, I guess visually there's the same graph we looked at before. This is what we're talking about. We're talking about frequency. The cycles per second. These are the cycles, and so you'd see there are more cycles occurring in the same space of time than in this wave, less cycles, and so this is a higher pitch. So the higher the frequency, the higher the pitch. Lower the frequency, the lower or deeper the pitch. And to put this into perspective, we'll talk about the range of human hearing. And so these are the frequencies that humans are capable of perceiving or hearing. And generally, kind of the max that we're looking at for this is 20 hertz to 20 kilohertz. And kilohertz simply means 20,000 hertz. So 20 hertz would be the very lowest bass frequency that you might hear. And you've probably had that experience where there's a bass frequency that's even lower than you can hear, but you can feel it, up to the highest frequencies that you might possibly hear. The truth is, most people don't hear more than 16,000 kilohertz, and that continues to get worse the older you get. And there are actually some interesting applications of this idea where there have been cell phones that have rings that are set to a frequency higher than most adults are going to hear, but teenagers who have that would still be able to hear it. And so it's been said that these kinds of rings can be used in a class, so a teacher wouldn't hear a phone ringing, but the teenager with the phone could hear it. Or the inverse of that, that maybe I've heard of in a public area where a city may want to discourage loitering. They set up an annoying high frequency sound that most adults who would have lost some of the hearing of higher frequencies wouldn't hear it, but again, youth or teenagers, they would hear that and be annoyed and not want to hear it. And so this is really helpful and applicable when we start talking about working with sound, when we're talking about recording, mixing, editing, engineering, all these kinds of things. We need to understand the different ranges, frequency ranges, and how to edit those appropriately. So generally, we talk about lows or bass frequencies. We're talking 20 hertz to 250 hertz. Mids, that's 250 hertz to 6 kilohertz or 6,000 hertz. And then the highest or treble frequencies are 5,000 hertz to 20,000 hertz. And an easy way to think of this, I mean, it's like your car or home stereo. It has an equalizer. That's what you're adjusting there, are these frequencies, these different ranges. So generally, you'll have these three kinds of things: a bass, a mid, and a treble, or a low, mid, and high. And you're just adjusting how much of a frequency you're letting through. Do you want more bass frequency to come through? Are you going to boost those signals, or do you want to take those down, and so on and so forth with all these? This is an interesting chart here that shows in different mammals the approximate hearing range. And you're probably familiar with this, that dogs have a higher frequency range. So a dog whistle is something that a human ear is not going to hear, but a dog will hear. They have a much higher range of high frequencies that they can hear as opposed to humans here. And just off the charts is something like a dolphin, where they can hear from 150 hertz to 150 kilohertz or 150,000 hertz. It's pretty incredible. So this is kind of fun to look at if you want to take some time to do that. Just give you some perspective on what different mammals are hearing. Okay, so frequency response is the range in which a uniform, undistorted signal can be produced. And sensitivity to different frequencies varies in people, microphones, and speakers. And so you'll hear about a microphone or a speaker having a certain frequency response. And again, that's the range in which a uniform, undistorted signal can be produced. That can vary within these different kinds of things. Okay, now let's move on to phase. Phase is the relative delay or offset between two sound waves of the same frequency. So what does that mean? This is really applicable when you're recording. If you have something, let's say two guitars, or actually you could have one instrument. Say you're recording a drum set, but you have a bunch of different mics recording it. You may have two mics that are recording the exact same frequency, from that same snare drum was producing the exact same frequency, but since they're set up in different locations, by the time that that wave hits the microphone, it may be in or out of phase, which means you can look here at this. There are these separate signals. So here's one and the other, they're the exact same. If they're in phase, so if they hit the microphone at the same time, what's going to happen? It's going to boost the signal, and so it becomes one larger mixed signal. It's in phase. Whereas if it's out of phase, you'll see where the peak and the valley of the different waves, the nodes are unaligned. It can decrease the signal, and so it's out of phase. So this is like noise cancellation. You've probably heard of different headphones or things that have these noise cancellation features. They're basically trying to get sounds out of phase so that they reduce sound. So phase is very important when we're looking at having two sound waves of the same frequency, whether they're in phase or not. And so this is basically what I just explained. The amplitude and subsequent loudness of a wave are increased if it's in phase. If they're out of phase, the amplitude and loudness of the wave are decreased. So again, if you want to look at this, we talked about amplitude. You can see there's a greater amplitude in this wave when they're in phase, and of course as these waves are out of phase, there's no amplitude there at all. So why might this be important to keep in mind when using multiple microphones to record one instrument? That's what I was saying about recording drums. You can get into more detail on that. Actually, we'll provide a link to a video that explains that a little bit, but it can get very technical as far as even measuring how far away a different microphone needs to be from the same source of a sound so that they will either be in or out of phase, so that you understand what you have there. So there you go. There's frequency and phase, and that ought to do it for that one.